How does Fourier's law work in real-world heat conduction? Imagine holding a metal spoon in a hot cup of tea. The part in your hand warms up over time. That's heat moving through the spoon, and Fourier's law helps us understand how that happens. Heat transfer by conduction is all about energy moving from hot to cold areas within solids or between objects in contact. Fourier's law states that the speed of this heat flow depends on three main things: the temperature difference across the material, the size of the area through which heat moves, and how well the material conducts heat. It also depends on the thickness of the material, with thicker objects slowing down heat transfer. Think about a metal rod heated at one end. The heat causes the molecules at the hot end to vibrate more vigorously. These vibrations spread to neighboring molecules, passing heat along the rod toward the cooler end. Fourier's law puts this process into a simple formula. It says that the heat transfer rate, which is how much heat moves per second, equals the negative of the thermal conductivity times the cross-sectional area times the temperature change over the distance. The negative sign just shows that heat flows from higher to lower temperature. In real life, this law helps engineers design everything from building walls to electronic devices. For example, in buildings, materials with low thermal conductivity are used to keep heat inside during winter and outside during summer. In electronics, high thermal conductivity materials help spread heat away from chips, preventing overheating. The law assumes steady-state conditions, meaning the temperature at each point stays the same over time, even though heat keeps flowing. This makes calculations easier and is often true in many practical situations. So, Fourier's law gives us a clear way to see how heat moves through materials. It connects the temperature difference directly to the amount of heat transferred, making it easier to predict and control heat flow in many systems. Whether it's a hot cup of coffee cooling down or a building staying warm, this law helps us understand the invisible process of heat conduction in everyday life.